Hello, Mr. Claudia here. Today we're going to be looking at how to measure central tendency. This is a nice way of saying how to find the middle value. Remember, in statistics, we have a lot of information, and the question is, how can I summarize all that information in a way that is useful to a person comparing different groups and different data sets? So one way of representing a bunch of numbers is with the middle number. Now, what do we mean when we say middle number? Well, you've heard these terms before: mean, median, and mode. So the mode is the most frequent value, so the number that happens the most. So in this example, the mode is the one that happens the most, which is 2. How do you remember this? I don't know. Think of a la mode, right? It means like very cool, so it's coming up a lot. That's one way. Now, that's not necessarily the way, for example, when you want to keep track of your marks, you don't ask for the mode, you ask for the average. You want to know the mean, in other words. The formula for average, again, this is the same as what you use when you find out your average marks. You take the sum of all the data values and you divide by the number of data values. This is one of the most common ways of measuring the middle value. The formula for mu, okay, the formula for mu then is, well, let's just do what we're going to do here. So it's 2 plus 2 plus 4 plus 5 plus 7 plus 8 divided by 1, 2, 3, 4, 5, 6. 6 data points. So that is, oops, sorry, let's make that clearer. So that is, and I can do that with my calculator, 2 plus 2 plus 4 plus 5 plus 7 plus 8 divided by 6. I get 28 over 6, or 4.67. So this is another central value. It's not the same as the mode, but it's very useful. For the formula then that we did, I mean, this is a process that we used. The actual formula is mu, so it's this nice letter mu, not the rare Pokemon, but it's a Greek letter. It looks almost like I like it to draw it as like a cursive U or an M. So that is the symbol we use when we're talking about mean of a population in this course. And the formal definition mathematically for this is the sum of from 1 to n of all of the data points divided by the total number of data points. That is the mean of a population. Do you like that? No, you probably like just following my instructions, adding up all the numbers, dividing by the total. But that's what this is. All the data points, add them all up. So x1, x2, x3, x4, all the way up to xn, whatever that is, and then divide by the total number. I'll just put a little note up here. Now, we've already talked about sigma at some point. Oh, we did integration, but let's just define it up here for those of us who don't know. So, for example, if I have x sub I, and I want to find the sum from 1 to I, or from I equals 1 to 5, well, this is really going to be x1 plus x2 plus x3 plus x4 plus x5. So this is big sigma. That's this Greek letter is sigma. It's the capital version of sigma. You might know another sigma. Actually, you will see it in a few lessons. Okay, so we have the mode, the mean. The final way of measuring the central value is to find the middle value of the set. So for this set, 2, 2, 4, 5, 7, 8, the middle value would be, well, 1, 2, it would be actually halfway between 4 and 5. So it would be the median is 4.5. The way we calculate this, well, we take the n plus 1 divided by 2th value. So in this case, I have 1, 2, 3, 4, 5, 6 pieces of data, so I take the 7 over the 2, which is 3.5 point. Now, because it's saying I need to find the point between 2 at the 3.5 value, I find the average of those two. So I'm going to put a little note there. if the number of values is even, then take the mean of the two middle values. So in this case, the 3.5 value, or the median, is the average of 4 and 5, which is 4.5. So these are all different ways of measuring the middle value of a data set. It's useful, right? If I want to compare our class average to last year's class average, if I want to compare this year's class to last year's class, one way I can compare classes is to look at their averages. That gives me an idea of the middle. Doesn't totally give me the best picture, but it's an easy number that I can use to summarize a whole population. Okay, so let's do a bigger example. Students in the class have the following height. So I measure a bunch of people. Calculate the mean, median, and mode. First of all, it's not super useful to be able to find out some of these things unless they're in order. So I'm going to order these. So I start with 158. Then I have 161, 161. 168, 170, 173, 175, 177, and 180. So I think I got them all. Okay, so now they're in order. So let's start with the mode. That's the easiest one, the one that repeats over and over. Okay, 161. The mode is 161. That's the most frequent number. The mean, that's a nice way of saying the average. Mu, which is the sum of all of the values from 1 to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I divide by 9. So I have 158 plus 161 plus dot, 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 all the way to 180, plus 180, divided by 9. Okay, let me type that into my calculator. Be careful, but quick. 158. Try to see. 158 plus 161 plus 161 plus 168 plus 170 plus 173 plus 175 plus 177 plus 180. That gives me 1523. Great idea to just write out this ancillary step in case you make a mistake. I can trace where your mistake happens. And my final answer is 169.222, but we should always round to 3 significant figures. So I get 169. So that's another way of measuring the central value. The third way is the median. So to do this, we have to look at the nth plus 1 value. So there are 9 values, so I have to look at the n plus 1 divided by 2. That's 10 divided. That's the 5th value. 1, 2, 3, 4, 5. So the median is equal to is 170. The median is not 5. It's the 5th value. So then I go and I count in order and I get the 5th value. Notice these are all different, right? They're all ways of measuring the central, the middle of this data set. How would a new classmate of height 205 affect the measure of central tendency? Whoa, we got an outlier. A very tall person gets added to this class. Okay, what happens to the mean? Well, I would take this number, 1523. I'd add my giant person, 205. And now I divide by 10. So my new mean is 178.2. Sorry, 172.8. Now my median, now I would go up to 10 values. So it would be, sorry, I have 10 values. So the 11th divided by 2. So I'd be looking at uh, 10 plus 1, which is 11 divided by 2. The fifth and a half the value. 1, 2, 3, 4, 5. So it'd be halfway between these two. So it would be 171.5. That would be the new median. The mode wouldn't change. So it'd be 171.5. Okay. So what do you notice? The mean went from 169 to 172. the median went up a little bit to 171. So this shows the pluses and minuses of both of these different central tendencies. Mean is really affected by the outlier. It went from 169 to 172. So this one tall guy really skews my number. Really makes, that class I'm going to remember is a really tall class, even though it's really just skewed by this one tall person. So mean is very affected by outliers. The 10th student skews the average to be higher. Median is less affected by outliers. I know you guys would probably default to look at averages, but medians are also a very useful way of looking at the central value of a data set. For example, consider I keep track of our class average. So this year's class, the average might be 85%. Next year it could be, or previous year it could have been 75%. So there's a huge difference. But it could be that last year when it was 75%, I actually had a really strong class, but then I had 2 students who never showed up to class. So they have a 5%. So their 5% really bring down the average. They really affect the mean. Those 2 outliers affect the mean. So often what I do what teachers do is they'll actually look at the median of their class, because the median tells you the middle student, what their mark is, right? The middle height or the middle student. So this year, my median student is 82. Even last year when I had those 2 very low marks, well, my middle student was still around at 82. So that might be a better way of analyzing a group of data. None of these are necessarily always right or always wrong. They're just presenting you different ways of looking at statistics. Let's do an example that has a frequency table. So students purchased 29 bags of M&Ms, delicious, and counted the number of M&Ms in each bag. They summarized the data in the following table. So they went through and remember there's 29 bags, but they used a table to present their data. So how many bags had 47 M&Ms? 1. 49 or 1. 50, 51. So you can see that most of the bags had 51 M&Ms. There were 12 bags with 51 M&Ms. So if you can imagine, we're going to do the mean, median, mode, but imagine what this data looks like. It's, okay, the first one bag has 47, then 49, then we have a bag with 50, another bag with 50, another bag with 50, etc., 9 times, and then we have a bag with 51, another bag with 51, ... all the way to 2 bags with 53. So can you imagine, there's this 29 pieces of data. So let's see. Let's see if we can look at the central tendency. First of all, what's the most frequent value? The mode. It's 12. 12 times we had the number 51. So my mode is 51. It is not 12. That's the number of bags that had 51. 51 is the data I've collected is number of M&Ms. So this is all the data I've collected. The one that's occurring the most is 51. Okay, the mean is everyone's favorite average. Mu is equal to the sum, I equals 1 to 29, of all the data points divided by 29. Now, what I could do is get my calculator out and start going. 47 plus 49 plus 50 plus 50 plus 50 plus 50. That's going to take forever. Instead, what I could do is say, okay, I'm adding 50 9 times. So what I'm going to do is multiply 50 times 9 and 51 times 12. So what I'm really doing is taking the value times the frequency. So I have 47, I'm multiplying that once, I'm adding that once. Then I have 49, I'm adding that once. Then I have 50, I'm adding that 9 times. 50 times 9 is 450. 51 times 12, that is 612. 52 times 4 is 104, 208. And 53 times 2 is 106. So then if I add those all up, because remember, what I'm trying to do is find out what happens if I add up all 29 pieces of data. So here if I add these up, I'll get that answer. So let me get my calculator out, and I go 47 plus 49 plus 450 plus 612 plus 208 plus 106, 1472. So I take 1472 and I'm dividing by the total number of data points, which if I added all these up was 29. I mean, that was given in the question. And so I end up with 50.7586, or approximately 50.8 Smarties or M&Ms. And finally, the last way I could measure the central tendency is with the median. I need to look at the 29 plus 1 divided by 2, which is 30 divided by 2, the 15th value. The 15th value is 1, 2. Okay, so this is the first one, second, then there's 11. So it's somewhere in here. It's the 51. Right? If you were to lay them all out, the median is going to, the 15th is going to be 51. So we have 3 ways of measuring the number, the central tendency of this data set. You could say it's 51. That's the one that comes up the most. You could say it's 50.8. That's the average. Or you could say it's 51. That's the middle value of all of my survey. I'm going to put a little star here that will help you with your homework. And there's an important star to note. For a grouped frequency table, use the central value of the range. So you will get some questions in your homework that go even a step beyond this. Instead of giving you the number of something exactly here, they're going to give you a range, and they're going to count the number of times things occur for a range. When you're doing this strategy, then you have to use the central value of that range multiplied by the frequency. This will make sense when you get to the homework. As you can see, this is a review. Most of these ideas are a review, but you can see that the questions can get a little more challenging, and especially understanding how the mean works and how new additions to the mean have an effect on the number. Okay, so your homework is, you know what, if I put it here, it's going to be hard to see in the scan. It is, oh well, page 261, number 1 to 2, 264, number 1 to 10, and 265, number 1 to 3. Okay, good luck with that, and we will see you next time.